Okay, I'm going to start. This is not going to be a super interesting stream. I'm going to repair my soldering line, maybe do a couple of other things. Not this soldering line. This is a new one. This works. I'm going to repair my good soldering line, which is here. So, apologies about the focus. I got a new camera and it focuses much quicker and it focuses really well, like to about here. And then it just falls off. So I'll try and hold things up to the camera when I can. So this soldering line, as you can see, is kind of in pieces. First thing I'm going to do is reassemble it, just to know how it goes back together. And then I'll explain a bit about what each part of it is, what the different bits do, and then fix it. So we've got a spring that goes here, and then this switch goes inside here. This is the heating element, so that slides in like that, and then this goes into the spring like that, and these are take into two holes here. So you can see like that. These plastic bits just poke into these holes here. Like that. I managed to get the spring out. Spring goes in there. You'll notice that this wire is disconnected. That's because we're going to replace it anyway, so it doesn't really matter right now. I just want to be sure that it goes back together and have an idea of how the wires are routed, because there is some kind of stuff you can move the wires around here. So this goes in here, like that. Okay, so see that this entire this entire switch element, I'll explain what that is a bit later, can spring up and down inside here, so you can see it. See it move up and down. That's what's supposed to happen. And then this just goes on the outside, and then gets screwed together. Yeah, so it's a fairly simple piece of equipment actually for something that's so kind of, you know, this is a Weller soldering line. These have a really good reputation, and this one is broken, but I mean it's probably like 40 years old as well, at least. And you can still get spare parts and everything for them. You can still buy this exact model brand new. It's a, I don't know if you can read it here. I'll put it up this way. It's a TCP-50. Not quite read it. Okay. Yeah, okay, you can't read that. And TCP range is a temperature controlled soldering line range. It doesn't have, so this will plug into a base unit, which will supply the power to this. And that doesn't have a dial for the temperature. The way it sets the temperature is using the actual tip itself. So if I pick one of these tips, you see here, it's got a number written on it. So this one is number 9. Yeah, it's good enough. So that's like a number 9 with a line underneath it to tell you it's that way up and not that way up. And that's the number of 100 degrees Fahrenheit that this tip is rated for. So this is 900 degrees Fahrenheit, which is way too hot for any kind of electronics. That's the tip that I got with the iron and that I was using with it initially, I think. No, I bought this one actually before I knew what the numbers meant, so I had no idea what I was doing. And you can see it's slightly discolored. That's because of the issue that I want to fix, which was that the iron overheats. So the temperature sensing doesn't really work very well. And the way it works is, I'm not really sure, but it works using magnetism and the Curie effect. So each of these tips has a magnet in it, and this switch has a magnet in it as well. So you see it kind of sticks to that. And when the soldering iron reaches a certain temperature, called the Curie point, the magnetism in this tip drops off. Right, so this tip is not as magnetic anymore. And I'd imagine what happens at that point is that there's some kind of spring-loaded contact in here that then retracts because there's not enough magnetism to keep it connected. And then that turns off the heating element. And then when the temperature drops below the Curie point again on the tip, the magnet will then connect, make the electrical connection again, and the heater will turn back on. So everything's controlled by the tip. So this is a 900 Fahrenheit tip. I have some other ones, 800 and 7 and 600, which is where you want to be for solder. 600 is, I think, about 350 degrees, which is good for lead-free solder, which you don't get in consumer electronics anymore. You can still buy it. And 700 is about 400 and something degrees centigrade, and that's good for lead-free solder. So I bought some tips. I probably need a finer one right now. I've also got another one here which I haven't tested, which is a pink tip, and I think that is 700 degree tip. Yeah, 7. So hopefully we can test it with this and maybe do some soldering with it as well if we're successful. But what we need to do is to replace this, I believe. So the issue I initially had was, like I said, overheating, and you can see it's kind of discolored all parts of the machine, like here. And then when I looked inside here, I could see that there was rust on the inside of this heating element. And I think you can see some tarnishing still inside there. So I cleaned it out as best as I could, polished it up, and it worked. Like the iron worked fine for a bit after that, but then when I went to pick it up a week or 2 or 3 or 4 later, it was not working again. And I looked inside and the rust had kind of come back inside, which you'd expect, right? It's exposed steel, hasn't been hot for a while, so the rust just came back, and the rust had built up on here as well. It was preventing this from moving. So now I think I fixed it again, and the same thing happened again. So I realized that, okay, there's more of a problem here than just the rust. So I cleaned out the inside, I applied some rust protector to it, and it's been sitting for a couple of months now, I think, and there's no new rust, so that's a good sign. So I applied some Loctite rust converter stuff to it. So that seems to have worked quite well. And now apparently this is the main failure point of these. So you can buy these brand new, which is what I've done. So this is it. This is the replacement part. Switch for TCP. So like I said, this has been in production for over 40 years probably. There we go. There's a new switch element with leads attached, which is quite useful because I don't want to go hunting for high temperature silicon leads, which you probably need in this application. So I have a feeling also that the rust in here, there was rust initially before I took it apart, but the kind of scratched, tarnished rust that you can kind of see in there, it's probably caused by scratches when I kind of put this in and took it out with the wires still attached. Because you can imagine if this wire, I said the focusing on this was a lot better on the camera, and now it's just proving me wrong. If you imagine that this wire here is still attached to this, then the kind of angle that you need to fit these back together, you're going to end up scratching the inside of that, right? So I'm going to put this, it's just going to completely, I'm going to put the new one inside and then solder. That's the plan. So and I don't think being a switch, I don't think that polarity matters, which is good because I just disconnected that and I can't really be bothered to go back in the video and find out where or why that happened, which way around it goes essentially. So I'm just gonna solve it back. They're both green wires. They should both be the same polarity. Yeah, cool. Let's do that. So the first thing I'm going to do is desolder these two green wires. I'm going to be replacing them. I don't know what kind of solder's on here. Like I said, it's very old. It's probably leaded, which is a good thing. I don't know if I have any leaded solder to solder back. But I'm just going to bend this contact here back slightly, so I can access the side that it's soldered to. And the same with this one actually. Same with this one. The focusing is really not good. Manual focus doesn't seem to work in this software on Mac as well, which is quite annoying. We need some way of holding this. Get some helping hands. This way as well. I wonder if anyone's watching yet. Mic's a bit funny. Can you speak louder? I can speak louder. I can also increase the volume in a sec. So I didn't even notice the chat. You speak louder. Increase the volume as well. It's 2 decibels. So I'll speak louder and I'll give it 3 decibels. Speak louder and use a filter to increase the noise. 5 decibels. That should be. Yeah, let me know if this sounds better or not. Okay. Some helping hands. So these are called helping hands. This is what you use when you want to hold things for soldering. This one's really fiddly, quite annoying to use, but it'll do the job. Have all these kind of joints and you can tighten them, reposition them, and then tighten them to kind of hold things in place for you, and you get a little magnifier as well. Move this actually. So I wanted to kind of move this way to get a bit more balance, but you can see there's a cutout there, so it's meant to rest on that middle bit. Back. Let me see if I can zoom down on this as well. So it's going to be a bit messy, but if I bear with me a second. When is Dr. Anita started? I've started, but I haven't started doing any actual work yet. Okay, so I've zoomed down onto that. I think that's good enough for now. Apologies once again about the focus. Maybe if I... Okay, that's not going to get much better, but what I could do is move this up, and then bring this up. Should be a bit better. Thanks, Hardy288. You know, actually, interesting thing, Wonder. When you first joined the other stream, I thought you were like an Indian bot or something. I didn't think you were a real person because you were acting so strange. That should do. If it focuses down here, I'll be very happy. Nope, that's the best we're going to get for now. Okay. We need some solder, which I have. Yeah, that should be enough. And that's leaded as well, so I'd just be able to wet that onto the existing loops. Actually, when I have these open pens, I'm going to hold this in there as well, and then I can just insert the new part into here before it's soldered. Hopefully, that's the plan. Okay. So this soldering line, which I'm going to use to do this, is it's quite cool. It's like a cordless soldering line from middle, and it uses a power tool battery, same as all their other power tools, which is super useful. Another thing I'm going to need is a fan to kind of blow away the smoke, because you don't want to breathe that when you're soldering. So I'll get that set up as well. Just give me a few minutes. So this just clips on, that way around, like that, which is very useful. And then it's got its own holder as well, which I probably won't use. I'll probably use my own because it's got a cleaning and some brass wool to clean the tip. You just turn it on here. There you go. Flashing means it's warming up. So give it a few minutes, and in the meantime I'll set up a fan to blow the air away, to blow the smoke away. My audio is very muffled. Let me give me a second. Let me see if this is any better. I'll turn this off. Is the audio any better now? I think part of the issue is that the MacBook is like working. The MacBook's like working really hard to stream the video, and the fan's like on full blast in the MacBook, and I think that background noise is causing an issue. So I turned on like noise suppression to get rid of that, but maybe it's made it worse. Let me know if this is better or if it was better before, and then I'll continue worse. Okay. The final thing I can do is use an actual headset, but then I can't like walk around, so I need to make sure I've got everything here. Yeah, let me get a headset. Give me a second. That's fine. Don't feel bad. Let me turn this off. Okay, is that better? This is the one I use for the Notion stream, so hopefully it should be a bit better. I need to clip it to myself though. Okay, actually I can hear it myself. Let me just make sure. Yeah, let me just listen to it myself so I can. Testing. Yeah, okay, that's good. Okay, cool. Yeah, if anyone knows of a good headset with let me just move this into frame. A headset with a good microphone, because that's something that's really hard to find, I think. Then let me know. Let me just move the camera as well, so we can see a bit more. Cool. Right, so this is warmed up. Just gonna clean the tip here. Even though it's brand new, I've never used this, but you can see they always put a bit of solder on the tip. You can see that kind of rough surface there. So I'm just going to clean that off. Cool. And then we should be able to take this wire off here. That's pretty easy. That airflow is not doing much. To move that fan closer, give me a second. This is the issue with the headset. Okay, that's as far as it will come. Yeah, I can feel that there. Hopefully that gets rid of the smoke. Right, so that's one wire off, and the second one is off too. And there's enough solder on these joints actually for me to just be able to, let's show you. Yeah, it's not very visible. There is enough solder there, essentially. You'll have to trust me for me to solder the new piece back on. So I'm going to take this, insert it into here. Gently. Doesn't want to go all the way through actually. So you can see it's got two pieces. It's got this initial section, which I'm guessing has the magnet, and then it's got some welds here, and then it's got the main body, which I'm guessing is where the actual switch element is. What's the holy smokes for, Munden? Okay, that's so just gonna fact, I might just actually assemble it here before I solder it in place. So please don't explode. All right, that was a comment on the actual smoke. I get it. Very good, very funny. 10 out of 10. Okay. Wish I could get it to focus a bit better down here. I can move the camera down a bit actually. Give me a second. It's this adjustment. That's actually a bit better, isn't it? Not completely fixed it, but a bit better. Headset coming in the way. Okay. So, okay, I've got this now. Actually, that's hanging down in a way that it's going to be quite easy to solder. So I might just solder it on now. So just need to kind of heat up the joint and then introduce the wire. It's not really working very well. It's a lot of heat getting into the wire, but maybe there isn't enough solder on that joint. So I'm going to do two things. I'm going to tin the wire, so I'm going to apply some solder to the wire itself, and I'm also going to apply some more solder to the joint. Okay. Yeah, the fan's working well. This is kind of old crusty solder on here as well. So it would be good to flow some more in. Just a bit though, not too much at all. Okay. Now, I think the tip that I'm using, the soldering tip, is too small for what I'm trying to do with it. Like, it melts the solder, but then when you have the wire as well, it's not happy about it. The issue with changing tips is you have to wait for the tip to cool down. I'm going to say that's good enough for now for that joint, and I'll come back to it. This one hopefully is a bit easier. Oh, I'm burning that wire. That's not good. You can also see this has started flashing, so it's not at temperature anymore. Bend this out a bit more so that I can get better access. Let's just check on the stream as well while I'm waiting for the soldering line. Cool. There's 3 of you here. Nice. I wasn't expecting anyone, to be honest. It's like a weekday and people have things to do. It's nice to have some company when you're doing this stuff. I'll probably do one tomorrow as well that's about 3D printer modifications, because I have a few of those to do, which if I can get the camera in the right place, it would be quite interesting to show. It's lost a lot of temperature. Look, you can see it's taking a while to get back up to temperature. Yeah, okay. Never do that. That's too hot. Just wanted to see if it was cold enough for me to actually change the tip for a bigger one. I do have a big one here. I'm not patient enough to wait for that. I'm just going to go for it again. Hopefully this time we're more successful. Nope, it's not even melting it right now. The other thing I could try, it's not really an easy place to put it. I'm lucky to have jobless mutuals. You're right about that. It's not really the easiest place to put it, but I could put some flux on. So this is called Flux, and it's essentially a cleaning agent, right? It comes in the core of the solder as well. There's no way it's going to focus on this, but maybe. No. Okay. This core of solder is actually hollow. When you buy solder and it says rosin core, it means that it's hollowed out through the middle, and it's actually got some of this stuff in it. It's got flux inside. So when you melt the solder, this burns off, and it basically decontaminates the area and allows the solder to stick. So I'm going to use some of this on here because I've already melted the solder on, so that flux has already evaporated or burnt off. So if I use it on there, it should clean the joint and it should allow the solder to flow a bit better. It just comes in a pen applicator, or you can get it in a tub. I've got a tub as well, but I've got nothing to apply it with. So if I just brush some on, maybe that makes life a bit easier. Thing is, you have to be quick, right? You can't be spending like 15 seconds soldering a single joint. You've got to be in and out. And when I think this soldering iron's rated at 20 or 25 watts or something. And this is a 50-watt soldering iron. This is kind of what you want to do work like this. Just having a look. It says 480 degrees. It doesn't have a power rating on it. And it's still warming up. Oh, maybe it has like an auto cooldown function, and you need to press the button again. Maybe that's what I did wrong. I didn't read the manual, because like, who reads the manual, right? Yeah, okay. So that's what it says on here, actually. I don't know if you can see it because my chat window's in the way. Give me a sec. Yeah, okay. So when it's flashing like it was before with like 1 second intervals, it's on its cooldown. You need to press the button again to get it to warm up, and it flashes quicker like this. So that was a bit of a waste of time. Tip looks good though, for a bit of soldering. A lot of the time with these tips, they just kind of disintegrate after a couple of joints. It's weird also that they haven't used high temperature wire here, so I managed to melt some of this wire with the soldering iron. This is just standard PVC insulation, whereas this is silicone. This is high temperature. I'm not going to, but I could touch this with the iron and it wouldn't leave a mark, whereas here it has kind of melted the sleeve a bit. Okay, so it's green again. That's a lot better. That's a good joint right there. Actually, there's a hole. I don't know if you can see it, but I'll show you that in a second, actually. I put this in and there was actually a hole that this has gone through, which you can see here, actually. You can see if I didn't realize that was the case. If I hold this up, you can see, yeah, right there. You can see that this contact is actually hollow in the middle. You can see it's got a hole in it. So they're all like that. It's just that the solder is covering that hole. So when I pushed this wire through, it's actually gone through. Again, focusing is an issue, but you can see that it's actually gone through to the other side. So that's useful information for this one now, because all I need to do is get the wire, melt the solder, get the wire through the hole, and then let the solder remelt around it. So I'm going to take it off. I'm going to actually clean up the end of this as well. You can feel the heat when you, even just by brushing it like that, I can feel the heat in my fingers kind of spreading up the wire. and you know you're spending too long on it, right? You're heating it up too much. So if I melt this solder on its own, and then push that through the hole, yeah, perfect. That worked really nicely, but there's no solder left. That's a really poor joint. We're going to need to introduce some more solder into that joint. There we go. That is a good joint. Nice. So I turn that off now. The soldering part is done. This is thankfully still attached together. So now it's just a case of, I'm going to snip the ends of these, see if I can give you a better view of that as well, and then reassemble, and then we should be done. I need to take my headphones off for this. Hopefully it doesn't make too much noise when I put them down. What is it? 4 o'clock. How long have we been going for? So it's taken longer than I expected. I'm going for... It doesn't even say. Yeah, who knows? Okay, so I won't need this anymore. So I'll show you what I've just done here. See if we can get you a good view. Yeah, there you go. You can. It's not perfectly in focus, but you can see how there's a spike here. That's the end of the wire that kind of came through the hole. And on this side you can't see it because it's just kind of gone down into the gap, which is a good thing. So I'm just going to bend this tab back. That didn't feel good. That felt like it cracked or gave way or something. Hopefully it's okay. And this one as well. I'm just going to snip off that sharp point of the wire with these, like that. I'll get some pliers to bend the tabs back as well. It's better. Cool. So they're all quite level now. You can see that. I'll bring it up. All kind of in line, which is nice. And now it's just a case of reassembling it, putting it back together, and then testing, obviously. So spring here, switch. You can see these wires are meant to go through this hole. There's a bit of strain relief for those. There's nothing similar for the green wires. It doesn't look like. It just kind of goes straight up. Those red wires are quite fragile. You saw how easily the green wire broke off as well, so I need to be quite careful with how I do this. So that goes in there. Okay, there we go. This white wire is kind of coming in the way. See that? It's like in between the spring and the... So I probably need to approach it from the other side. Where you have that. The green wires come through from the other side, which would mean doing some gymnastics here without breaking anything. This plastic is flexible, but it's more the kind of pressure on the inside of here, the tension and the metal that I'm worried about. It's these red wires that are kind of being stretched to their limit here. If I can bend this plastic, then that'll do it. Just go give it some brute force. There we go. That should hopefully fit a little bit better. Might do what I did initially and just put these plastic lugs in first, and then put the spring in. Like that. This is like the least technical and most difficult part of the process. Okay, there's one. And there's two. See, actually the switch has changed over the years, so the old one has this clear casing on whatever this is. This one has probably cheaper blue one. Okay, let me put this in as well. Cool. And then hopefully this should spring down and back up, which it does. It does quite nicely. So now just need to reassemble everything, which just involves sliding this stuff up. And making sure that everything I've already connected stays connected, which is easier said than done. Okay. So, in again. So I could kind of heat stake these on using the soldering iron again, melt the plastic to make it stay put. It's probably not a good idea because if I need to take it apart again, then I need to replace that entire part, and that's probably the hardest part of the soldering iron to replace. But this looks like it's kind of going back together quite nicely now. Not. Okay, let me get this on, get that ring on, and then worry about the rest. So push this back through. So you can see there's quite a bit of interference here. You've got these three places where screws go in, and then you've got this kind of brace section which is wider than that. So the orientation of all this with regards to each other matters, and then you've got this switch which sticks out to the sides as well, and that obviously has to be free to move against the spring. So it's not super easy. It's not the most complicated thing in the world, but it's also not the easiest. Again, we've got just like tangles of wire interfering with what we want to do. Maybe it goes like that. Maybe that's... No, it's not that. Apologies if I'm not giving much attention to the camera right now, because this is really, really fiddly. The spring isn't really helping either, because it kind of grasps on and then prevents rotation here, which is probably part of the issue. We'll try again. Okay, so that's in. That's not lined up. So it does need to be rotated like that. I'm wondering if maybe the spring's a hindrance again at this point. Take it out. Maybe I could glue here. The thing is, it's going to get so hot it will burn off, but maybe just as a temporary thing while I'm assembling it, it might make things harder. I don't know. Okay, so if I get this now far enough up, I can still place the spring, but not. I'm going to compromise how well everything's going to line up when I put it in. It looks like I might be getting there. It's just come out again, but I'm not too worried actually, because we're quite close. Okay, so now pretty much got everything lined up, and if I just pull through from here, hopefully, there's this rubber sleeve here which you have to kind of get beyond this groove here. But then this is the closest we've been. It needs a bit of rotation, but not too much. I'm just going to pull through, and that looks like about it. So the only thing I want to do right now is, before I screw it together, is check whether the spring action is still working. So I'm going to put a tip in and see that I can, yeah, let's see that's got free motion inside there. So that's good. Let's screw it back together. I'm sweating. That was quite intense. Trying to get all that lined up. Not tightening the screws all the way down. Firstly, because it's plastic. Secondly, because I want to make sure that everything's aligned before I tighten it down fully. And thirdly, because when you're kind of screwing into a flat flange like this, you want to kind of creep up on each of the screws gradually so you get an even tension all the way around. You can see here also that, you can see there's a bit of a gap there for this ring piece. So you want to make sure that that's seated the same all the way around as well before you tighten anything up. I realize this is like a very boring stream, but I understand why chat's very quiet. Hopefully the 3D printing one that I'm planning to do tomorrow will be a bit more interesting. There's a lot more kind of theory that I can explain in there. Whereas this, I don't really know how it works. I'm just kind of putting it together, and it's a fairly simple device as well, right? Okay, Make sure this is pulled out all the way. And okay, it's time to test it. You're going to see live whether what I did worked or not. So there's other bits of this that could be faulty, right? I found out online that the switch element that I replaced, where's it gone? Where's the spare one gone? The old one. That this is the thing that usually turns faulty. And they said that percussive maintenance usually fixes it, and that kind of worked for me for a bit. Percussive maintenance basically means hit it with a hammer or hit it on the desk, as I did. That worked for a while, and then it just stopped working. But you can see how tarnished this is. I don't know if this is meant to be electrically conductive. I don't think it is. You know, all of this stuff. And the second-hand prices of these irons has gone quite high now. So what I paid for a replacement of one of these 2 years ago, I'd have been able to, on eBay, replace the whole iron. But it's good to kind of recycle and reuse things, right? So let's screw this on. No, with a tip. Need a tip. So I want quite a low temperature tip, because then I'll be able to tell if it's overheating. It used to get literally red hot, like it used to glow red. So hopefully it's not going to do that anymore. So that's 7. And I can pick up something that we can try and solder as well, so we can actually do something useful with it. I'm really bad with like misplacing things, and I realize I have a video in front of me where I can figure out where things went, but being stubborn, I'm not going to look for it. I'm looking for the thing that's already on here. So this goes on over the tip. It's there. And you can see why the spring action is useful actually, because so we have this thread. I have a thread down here. And the focusing on this camera is really not living up to what I said it was. Yeah, so my hand's like perfectly in focus, but then this isn't. There's a thread here, there's a nut here, and you can see the kind of standard range of movement doesn't let those two come together. And when you push the spring down, that whole section, including the tip, which is what's actually pushing against the switch, which is pushing against the spring, kind of comes down. And then you can tighten up this nut like that. And I should probably give that a little tweak with a spanner as well. I should measure how big it is, and then I'll get the right spanner and get something to solder with it as well. And the power supply. Obviously this needs to plug into a power supply. It doesn't run off mains, it runs off 48 volts, 24 volts. So it's 50 watts, 12 mil. Cool. Okay, I'm going to mute my microphone this time because it did look like it made some quite big noises when I took it off. So I'll mute it, and if I come back and I'm doing stuff and you can't hear me, just like put a note in the chat because I'll have forgotten to unmute it. Okay, I'm back. I just had a moment of absolute panic there because I saw the soldering iron like touching my headphone cord, which obviously is not a good thing. So this is the power supply. Just takes an IEC cable in, and the soldering iron plugs in to it over here. It's keyed, so it only goes in one way. I think you can see, yeah, there's a key in the connector there. That's that way up. And then it locks into place like this. And then you can turn it on, which I won't do yet because I don't have anywhere near the space right now. Put this here. I've got to be really careful of my headphone cable now because I do not want to burn it. Okay, so I'm going to turn that on and we'll see if it works at all and if it overheats or if it like lets the smoke out or sparks and dies or whatever. And in the meantime, I need to find something to solder. So got some parts for one of my 3D printers. And what I need to do is I need to change a configuration setting on this driver board. Okay, you can see some smoke there, which is normal. Like there's going to be some smoke that burns off initially with new parts. Turn the fan back on. Iron Man suit giveaway when? Iron Man suit giveaway at like 1 million subscribers, maybe. Yeah. Okay, so try briefly to explain what this is and then what I need to do to it while the soldering iron's warming up. Although this is, like I said, 50 watts, so it should warm up pretty quick. But I want to leave it for a long time. I want to see if it overheats. So this you can see here. It says Lurge, which is the manufacturer, in TMC 225. TMC 225 is the chip that's on here. It's a driver chip. And TMC is short for Trinamic. Trinamic are a German company that make stepper motor drivers. So, in fact, I've got a stepper motor not to hand right now. Moved it off the desk. So, a stepper motor is basically a motor that retains its position, right? So, if you imagine like an electric car motor, when you let go of the accelerator, the car keeps moving and the motor keeps spinning. Stepper motors don't do that. They're positionable, right? So they can rotate a number of times if you tell them to, or they can rotate to a certain position if you tell them to. And this is a controller chip that controls how that happens. So you get a bunch of these in your 3D printer. Most 3D printers have 4 stepper motors, so 3 for the movement axes and then 1 for the extruder that extrudes filament. And I want to use this as a filament extruder. And that means that it's better for me to change a configuration on the motor because it has like a silent mode and it has a powerful mode. And for the extruder, we want the power and not the silence because you do things called retractions on a 3D printer, which means you're pushing filament through and you're melting it. You're melting it into the shape that you want. And then when you kind of want to stop and want to move somewhere else, right, to print another part of the thing you're making, you need to retract the filament, right? You need to pull it back through the extruder so that you don't get like melted plastic oozing through it. And so that retraction moment is very violent, right? It's going from a forward motion immediately to a backwards motion. And the silence logic in this driver will see that and will kind of smooth out that curve. It won't be a sharp retraction. It will be like a smoothed out, change in movement. Decelerate and accelerate, and that's not what you want. You want to go from acceleration to deceleration as quickly as possible. So I need to change a configuration on this, and I emailed the manufacturer and they said change J5. So I have no idea if this is going to focus, but you can see there's 3 sets of solder pads here. So there's the top one which has 3, and then there's 2, and then the one next to my finger has 2 points, and that's J5. So I need to bridge those contacts. They're just contacts right now. They're just 2 blobs of solder. I need to bridge them, join them together essentially. That's not gone red hot, which is a good sign. So I'm going to look up what he told me to do exactly, and then I'm going to do that, and then we'll know whether this is working well or not. I'm just going to check my email to see what he told me to do. Should have kept an eye on Twitter as well to see if any of you are complaining about the audio or anything. But if there are any complaints, put them in the stream. They're not complaints, they're like useful feedback. So it's good to see. Right, check email. Okay, so he said TMC 2225 is configured in stealth chop by default, so stealth chop is the silent mode. If you want to switch it to spread cycle mode, which I do, you can solder the two joints of J5 together on the back of the driver. So he's saying you don't even need, I asked him, should I put a 0 ohm resistor in there or something, or a resistor of some value? And he said no, just bridge the contacts. So that's what I'll try. But I have a feeling I might need some wire in between them. But we'll give it a go. We'll see what happens. So it's okay. No more suspense. We're going to do it. We're doing it right now. Okay. This is really small. This is where actually the magnifying glass would come in handy. Let's see if I can get that set up. These helping hands are so fiddly. This is the only pair I've ever used, so I don't know if they're comparatively good or not compared to what else you can get. But they're so fiddly. Okay. That actually works quite well. That looks like it's going to do its job. Okay, so hopefully you can get a view of this as well. It doesn't completely flip over. Okay, I can see that really clearly. You obviously can't. So apologies about that, but yeah, maybe the new camera was not a wise investment, but I didn't just buy it for this. To prevent this flipping over, maybe I can add some kind of counterweight here, like pliers. Is this a stupid idea, or maybe a screwdriver? Yeah. Okay, so I just need to bridge these two contacts, is what he says. Triple check, it's J5. If you want to configure spread cycle, you can solder the joints of J5 together. Yes. And check the wiring diagram that he has as well. It says J5. So J5 is this bottom. You can't see it, apologies. Bottom set. It's not overheating. That's good news. It should be warm. It is warm. That's also good news. Okay, I'm going to use Flux here. I'm not sure what Flux is going to do, whether it's going to make things better or worse, but I feel like I should. Apply a bit of Flux. Yeah. Just between those two joints to make the solder kind of wet them, because I don't want to solder. The fear, of course, is soldering the wrong two as well as the right two. I'm just going to wet my tip there with some solder, and then this is probably the finest soldering I've ever done, so a good test of the iron. Don't actually know if that's bridged. No, it's not. We don't have enough solder there. It's not flowing outwards from the joint, so that's a good thing. There we go. I think that's bridged. You can do this kind of thing just with pencil, when you're just kind of soldering two pads together. The graphite in a pencil is usually conductive enough, but obviously this is going to be inside a 3D printer with vibration and all sorts of things happening, so I don't want to risk that. Okay, those pads are soldered together. So if maybe I can show you. a bit more closely. Yeah, you can see it. So you can see, whereas here and here you have 3 distinct dots, 2 distinct dots. Now we've got a blob that goes between those, and it's not the best solder joint in the world, but it'll do. I was very aware of the heat of this iron when I was doing it, the power of this iron, because you just want to touch it for a fraction of a second, otherwise it's going to overheat the joint, it's going to burn your PCB, and that's been my kind of experience with this iron, partly because I was using the wrong tips. I was using too high a temperature. Maybe I need to go lower as well. So these are 700 degrees. Maybe I need 600 degrees, but that works quite well. If I can, they don't make all of the tips anymore. If I can, maybe I'll get a 600 degree Fahrenheit tip in this size, because this is a good size for me. But yeah, it worked. Success. I was going to do some more on this stream. I was going to rewire a new stepper motor that I got, or rewire a new fan. The stepper motors for tomorrow. But that's even more boring than this, and also, like, I think this is enough for today. So I'm going to close it out here. And I'll probably just leave this video up as is, no editing or anything. It was nice to have you here. It was nice to have some company while I did this. Have something to talk about. So, cool. Yeah, if there's any questions, leave them in the comments on the uploaded video, and I will answer them. And hopefully I'll do another stream tomorrow where I can attach the camera to the 3D printer itself while I'm working on it. And hopefully there's going to be less focusing issues there, because this is where it begins to fall off, I'm guessing. And my tripod that I've got this attached to doesn't really go much lower than this. So yeah, thanks for being here. And I don't know how to wave. How do I wave? Bye. Okay.